Today's lesson is your review for your Unit 3 test. The first couple of questions on your test today are going to ask you to graph an absolute value function, much like this one. It's going to ask you to label the increasing and decreasing parts. Please do not forget to do this because some of us forgot to do that in the last part. So let's go ahead and graph. I've already gone ahead and put this in my graphing calculator. I identified my vertex and I got myself 2 points to the left and 2 points to the right. So the points that I came up with were -2, -5, -1, 0, 0, +5, and then 1, 0, and 2, -5. And then I'm just going to go ahead and connect them together. There we go, just like on my calculator screen. Once I have done so, I'm going to go ahead and I'm going to put the increasing and decreasing parts. Now, it might be helpful for you to, at this point, identify if your vertex is a max or a min. Because if you do that, you can look in your notes and then you don't have to worry about if you got the increasing and decreasing parts correctly, because it's going to match whether your graph is a max or if it is a min. So you just have to decide, is this point right here, the vertex, is it a max or is it a min? Is it the high point or is it the lowest point? Well, yep, if you said max, you got it correct. And so if you look at the example in 3.1, I do believe it was example 2, it will say that when I read over here on the left side, remember you start at the arrow. The arrow's not pointing in the direction of increasing or decreasing. The arrow is your starting point and it's going up to your vertex. You always come up to the vertex. And so this side is increasing. And then, of course, at the vertex, it turns and it goes in a downward direction. So this side is decreasing. Not a lot of people got that wrong on the quiz. If you did, it's because you forgot to do it. So let's go ahead and get it done as soon as you have graphed. The vertex is right here as well, which is that point 0, 5. From your vertex, it is very, very important that you know which one is the y value. It is very, very important in your vertex to know which one is the y value. And the reason for that is because of your range. You're going to need that y value of your vertex to do your range. Remember, your domain are your x values. And the domain is the same for all our examples. If you look through 3.1, it's the same for the parent as it was for example 1, as it was for example 2. It is going to be -infinity, positive infinity, all the real numbers. But this is the quickest and easiest way to write it. Now, what you're going to do for the y value is, you have to use 5 because that's the y value. Remember, the first number, the first number is your x value, so you don't want to use the first number. You're going to identify your y-axis. It's the one that goes up and down, and you have to know where positive infinity is. Well, it's going to be right there by the +10. And you have to know where the negative infinity is. It's going to be down here by the -10. Watch your graph. Now, what's going to happen is you just want to look at the arrows of your graph. That's why it's so important to put the arrows on, because the arrows are going to tell you which infinity to use. Notice that my arrows are both pointing towards -infinity. So for my range, I want -infinity, not positive infinity, and I want the y value from my vertex. That's it. There's my vertex, there's my range. I just have to know which number goes first. To do that, I look at the range, I look at the domain. The domain tells me that first is -infinity, then comma, positive infinity. So if my range must include -infinity, it must go first. It always gets a parentheses. I grab my number that's my Y value of my vertex, and it gets a bracket every single time. All right, let's move on to the next questions. The next set of questions are going to ask you to solve an absolute value equation. Be very, very careful because there's equations to solve, and then there later in the next example, there will be inequalities to solve. You do them both pretty much the same, but remember there's that one trick on the inequalities, so we'll do that when we get there. Before I can go ahead and solve this, remember I have to make sure that the absolute value is by itself. Alas, it is not. I have to get rid of the 5 in the front, and I have to get rid of the plus 6 that's after the absolute value. So I'm going to draw my line, and I can think of this like 5x plus 6 equals 76. To solve that equation in the laser, I would go ahead and subtract 6. So I'm going to do that here as well. If I take away the 6 from both sides, it leaves me the pink 5. It leaves me the x minus 5 inside the absolute value, which is in purple, and it gives me 70 on the other side. I can see once again that my absolute value is not alone. So I must go ahead and get rid of that pink 5. Remember, I'm thinking of it like this. To get rid of the pink 5 or the 5 in the laser, I would divide both sides by 5. So I'm going to do that as well. There we go. And now my absolute value is all by itself. There we go. I almost forgot it. And I get 14. Now I can go ahead and I can solve my equations. Remember, an absolute value always has two answers. You must give me two answers. That's why the and is there. They do not have to be the same sign. They do not have to be different signs. They can be the same. So they could both be negative or they could both be positive, or you could have one and one. The first equation that you're going to solve is just getting rid of the absolute value. You pretend it's not even there. To solve this equation, we're going to go ahead and add 5. 14 plus 5 is 19. There's my first answer. And there's a second one. Remember, you're going to take that purple part inside and you're going to set it equal to negative 14. The beauty of these equations is that you solve them exactly the same way, so you don't have to think about solving. Please make sure that you put this in the calculator and you check it because negative 14 plus 5 is not negative 19. It is in fact negative 9. Make sure you put it in the calculator and check because what a lot of you are doing is saying, well, I got positive 19, the other one must be negative 19. No, no, no. Check. Make sure. All right. Let's go on and take a look at the absolute value. Now, I picked the very hardest absolute value because we didn't really talk about these in the lesson. The ones we saw in the lesson were very, very simple, but you are going to see ones like this. Remember that before you can actually break up your two equations and solve, you need to get the absolute value by itself. So this part right here needs to be alone. I have to get rid of the 3, and I have to get rid of the plus 6. Let me go back to my pink. All right, remember you can think of it like this, and you can think of this as an equal sign. That's why the bar is nice to put between them because then you don't have to worry about the sign. I'm going to go ahead and subtract 6. It's going to run me into a little bit of an issue here that I'm not going to like, I have to admit, because 19 minus 6 is 13. Now, I used my calculator from here on out because if you're using your calculator, you're following along, I'm going to divide by 3. Well, 3 does not go into 13. In fact, it gave me a fraction. So I just left it as a fraction in my calculator. But I did ask myself, is that inequality up at the top, this one right here in the circle, is it going to flip? Remember, it only flips if I divide by a negative. So I'm going to check these guys right here. They are not negative, so it's going to stay the same. Now I can go ahead and I can set up my two answers. Remember, there needs to be two dots on your number line. I'm going to be grading you based on your number line because I'll know you did your math correctly if the number line is graphed properly. All right, so remember we take the stuff inside this purple part right here. And for the first equation, we're simply going to leave it exactly how it looks, just like that, just like that. We're not going to change a thing. Remember, this sign can flip, but remember, if it doesn't flip on the first one, it's not going to flip on the second one. All right, to get that x by itself, I would subtract 7, and I went to my calculator. And I put this in, and it gave me negative 8 over 3, negative 8/3. I did not divide, I subtracted, so my sign will not flip. I also went ahead and had the calculator tell me what negative 8/3 was as a decimal because I felt it was easier to graph. I thought I can graph easier than a fraction. Okay, so I went ahead and did that. My other equation, remember, is the purple part inside, the negative of the number on the other side, and then the fraction has to, or the inequality has to flip. The fraction stays the same. The fraction becomes negative. Um, I didn't flip, I did not flip the inequality on the last one, so I know it's not going to flip back again this time. I'm going to go ahead and subtract my 7. And once again, I used my calculator because it's a negative fraction minus a whole number. And I had to make sure that my head was thinking properly. I got negative 34 over 8. Oh, no, sorry, over 3. And once again, I put it into a decimal so that I could graph it easier. There we go. There's the two numbers that I should see. So I'm going to go ahead and put 0 right here. I'm going to go ahead and I'm going to put -1, -2, -3. So there's my -2. And then down here, I'm going to put negative 18, -19. This is just helping me to figure out where those circles should go. It's okay not to put the numbers in between. For negative 2.6, it's going to go right here close to 3. There's no bar underneath, so I'm going to go ahead and leave it open. For negative 18.3, I want it a little bit closer to 18 than I do to 19, so I might make that space a little bit bigger. If you want to, because it makes you feel bad, just go ahead and get some lines in there. No worries. All right, remember that when the x is first in my inequality, this is an arrow telling you exactly which direction to shade for this number. It's telling me at this number to shade to the left. So from this number right here, I'm going to shade to the left. So it's going to shade until it gets to the arrow, and then it's going to continue going on. Could come in and make this nice, and there we go. Now the other side, since the x is first, this becomes an arrow telling me exactly where to shade at this number. I'm going to go ahead and shade to the right, and it's going to shade to the arrow as well. There we go. That's it. Okay, please make sure I can tell where you're shading. Remember, the only other way to shade would be to shade in between. Yes, if they had flipped, if this one had been going this way, I would have shaded from here till I got to the circle and I would have stopped. I stop when I see a circle or I stop when I get to the arrow. Okay, All right. The last question on our test today is going to ask us to graph once again, and then it's going to ask us to explain how this graph, this one right here, has been, there we go, this one right here, how it has been transformed from my parent function. My parent function is this one right here. Down below, you're going to see that I've helped you out by giving you a key as to what to tell me about the transformation. But I'm going to go ahead and show you the graph first. So I went ahead and graphed this, and I have the points 0, -11, -1, -7, -2. Oh, wait, oops, that was wrong. -1, -7, there we go. -2, -3, -3, -7, and -4, -11. There's my graph. Now I need to make sure that I write down everything that happens. And I'm going to follow along exactly. So the first thing you need to look for right after the equal sign is, do you have a minus? So go ahead and look right after your equal sign. Do you have a minus? I do. So I am going to write these words. If you do not, then you do not write it. Half of you will have it. Half of you will not. So I have to write it because I have that. So I'm going to write reflected over, or I could use the word across the x axis. I'm going to put a comma because I need to continue on now to the orange part. I'm going to look at this number. My number is 4. I'm going to find that number right here. Notice my number is here. So I'm going to write stretched by a factor of 4. I didn't give myself enough lines. Okay, I need to continue on because there's going to be a number here. I have a number here and I have a number here. Now, when you guys see yours, you're either going to have this one or you are going to have that one. So be very careful. Watch where your number is. If your number is inside the absolute value, then it is H, and you're going to write moving left or right. Notice if it's plus H, it's left. If it's minus H, it's right. So let's take a look. Mine says plus 2, so I'm going to pick this one. I'm going to pick this one. Let me show you with some little, I picked this one, and oops, I picked this one because I had it. If you don't have it, oops, if you don't have it, then don't use it. Just don't use it. All right, so then I'm going to say moves left, or well, I could say 2 units. 2 units. And then I'm going to say and, because I'm going to have a K, I'm going to have a K. Notice I have a -3. Look at what I've done for you. If it's plus, you put up. If it's minus, you put down. I have this one. I have this one. So I'm going to say and down 3. I guess I could have put the units at the end. I didn't need this one. All right, ladies and gentlemen, will you have to fill out all of this? No, but just a heads up. Half of you will have to put this, the other half will not. Almost everyone is going to have to tell me that they stretched by a factor of, and then they're going to have to tell me what their number is here for A. Half of you will tell me that you moved left or right, and the other half of you will tell me that you moved up or down. Good luck, you guys. You've got this.